Welcome to lesson 2.2, calculations using equilibrium constant expressions. If you need to look at the textbook, it's pages 22 to 24. Lesson objectives for today are to be able to construct an expression Kc for a homogeneous system in equilibrium and be able to perform calculations involving Kc. So we're going to look at an example for calculations involving Kc. And for this, we've got this completely made up equation: P plus 2Q goes to R plus S. And we're assuming that all species are aqueous. And in this question it says 1 mole of P and 1 mole of Q are mixed. Once equilibrium has been reached, 0.6 moles of P are present. How many moles of Q, R and S are present at equilibrium? So in order to work out how many moles of Q, R and S there are at equilibrium, we need to use the combination of the information in the question and the chemical equation that we've been given. So in questions like this, I would suggest that the best way of tackling it is to set out, either in a table like this or just as a series of lines, to set out the initial number of moles of each species, then the amount that's reacted at equilibrium, and then the amount that's left at equilibrium. So this is completely blank at the moment. I'm going to show you the next slide. We're going to put in the information that we already know. So from the question, we know that 1 mole of P and 1 mole of Q are mixed. So we know that our initial number of moles of P is 1 and our initial number of moles of Q is 1. We haven't been told about R and S, so we're going to assume that they're 0. So here's the completed table, as I just said. So 1 mole of P, 1 mole of Q, none of R and none of S. So then we need to look in the equation, in the question, and see what other information we've been given. And it says once equilibrium has been achieved, 0.6 moles of P are present. So we can fill in the column for P so that it shows that at equilibrium, so the bottom row there, at equilibrium, it's got 0.6. So there we have all the information from the question represented in the table. So now we need to figure out how much has changed for P. So if we started with 1 mole and we've got 0.6 left at equilibrium, then we must have used up 1 minus 0.6 moles, so we must have used up 0.4 moles. So we can fill that into the table now. So now we need to look at Q. And if we look in the equation, we know that 1 mole of P reacts with 2 moles of Q. So if 0.4 moles of P has reacted, then that must mean that twice that amount of Q has reacted. So we can now fill in the Q column that 0.8 moles have reacted at equilibrium. And then we can work out how much is left at equilibrium. Because we started with 1, we've reacted 0.8, so we've got 0.2 left. So we can now fill that in the table. So all that's left is for us to look at R and S. So we know we started with no moles of each of those. And if we look at the chemical equation, 1 mole of P gives 1 mole of R and 1 mole of S. So if we look at P, we know that 0.4 of it has reacted. So if 1 mole of P gives 1 mole of R and 1 mole of S, then 0.4 moles of P is going to give 0.4 moles of R and 0.4 moles of S. So we can now fill in this table. And this now tells us the amounts of all of the substances at equilibrium. But of course this isn't the end of the story, because what we want to do is calculate Kc. And Kc involves concentrations, and this is just the number of moles. So we need to bring in the volume, and we can do that on the next slide. So here we have the expression for Kc, which you should be able to work out. It's the concentration of R times by the concentration of S, divided by the concentration of P, and then the concentration of Q squared, because you've got 2Q in the equation. If we now plug in our figures, so at the top we've got concentration of R, which is 0.4 divided by V, and then S is 0.4 divided by V. So we've got 0.4 divided by V times by 0.4 divided by B. Then on the bottom, we've got the concentration of P. So our amount left at equilibrium is 0.6, that's 0.6 divided by B. And then for Q, we've got to square that, so that's 0.2 of Q that we've got left. So it's 0.2 squared divided by V squared. Now we're going to make it really simple here and say that V is 1 decimeter cubed. And in that case, we can just ignore V, because it's just going to be divided by 1. So if that's the case, Kc then becomes 0.16 divided by 0.024, which if you plug into your calculator is equal to 6.67. So let's look back at our lesson objectives, which hopefully you've met, which are to be able to construct an expression for Kc for an homogeneous system in equilibrium, and to be able to perform calculations involving Kc. As usual, if you don't feel you've met these, then you need to go back and either watch the video again or look at the textbook or some online notes in order to make sure that you've reached all these objectives.